Let's do a few examples with the chain rule, just seeing it in practice, how to compute these derivatives. So for instance, let's start out with maybe y equals sine of x squared. Now the quick way to do this is to think of like an outside function like sine of x and an inside function what's being composed that's x squared. And so if you want to find y prime, the way you should think about it is you should think derivative of the outside function, in this case that's cosine of x, plug in the inside function, then multiply by the derivative of the inside. Derivative of x squared gives you 2x. If you want to go back and ask yourself, what does this actually have to do with the statement of the chain rule? What's getting plugged in here? Then the way you want to think of it is your outside function, that's your f of x. And your inside function, that's your g of x. So in this case, f of x is like sine of x and g of x. That's like x squared. F composed with g, that's sine of x squared. The derivative of that is f prime, plug in g of x, times g prime of x. But in practice, you're going to want to think about it as just what's the outside function, what's the inside function. Take that derivative, plug in your inside function, multiply by the derivative of the inside function. Let's take another example. Let's try to do maybe y equals e raised to the power of cosine of x. So how can I do that? Well, this one, I'll set it up for you step by step. I'm going to let my outside function be e to the x. I'm plugging something into that. So I'm thinking of f of x equals e to the x. My inside function, what's being plugged in? That's g of x. That's cosine of x. And if I want to find y prime, then I need to take the derivative of my outside function. The derivative of e to the x is e to the x. And I want to plug into that cosine of x. So I get the derivative, plug in cosine of x. And I have to multiply now by the derivative of g of x, by the derivative of my inside function. And the derivative of cosine of x, that's negative sine of x. So the answer here is going to be e to the cosine x times negative sine of x. And that's just me writing down f prime plug in g of x times g prime of x, where my g prime of x is the negative sine of x, and my f prime is e to the x, f prime of g of x, that's e to the cosine of x. Let's do another one. Let's take y equals tangent of, I don't know, let's say e to the x. This time I want to think of e to the x as my inside function. It's being plugged into a tangent. I want to take the derivative of this. So now I'll just take the derivative without writing down explicitly what f and g are, but try to keep it straight in your mind. Your f is tangent of x, your g is e to the x. So what you're doing is taking the derivative of your outside function, derivative of tangent, now we know that's secant squared, and then we're plugging in e to the x, right? That's derivative of outside, then plug in the inside function. And now you multiply this by the derivative of your inside function, the derivative of e to the x. It's e to the x. So once you get the hang of this, you'll be able to do it super quick. Whatever function you've got, take the derivative of that outside function, go ahead and plug in the inside function, then multiply by the derivative of the inside function. Let's show just one more example, and this is going to be a little bit more theoretical. This is going to help us when we do implicit differentiation a little bit later. So say that I have y equals f of x But this time I'm not going to give you a formula for f of x. I'm just saying y is equal to some function. It could be any one of those. It could be something else. And say that in Leibniz notation now, I want to take the derivative. This is Leibniz notation for taking the derivative of y squared. And so what's this going to be? So this time I have an outside function, which is taking the input and squaring it, right? Like f of y equals y squared. And my inside function is actually f of x. So I've got f of x raised to a power. Now the chain rule tells me I have to take the derivative of my outside function. The derivative of y is 2 times y. And I multiply it by the derivative of the inside function. The derivative of the inside function is just y prime. And so one thing that students get confused about initially is they see this expression and they want to say that the answer is just 2 times y. That would be true if you had d over dy. It would be true if you were taking the derivative with respect to y. The answer would be 2 times y, but that's not what's happening here. You've got y squared. You're taking the derivative with respect to x. So you need to use that chain rule. You're going to get 2 times y times y prime.